We're looking at example 4, all right? Nonlinear systems of equations, assignment 30, our last assignment together, our next to last example that we'll enjoy together this semester. All right, again, I've always felt compelled to very quickly talk about the underlying graphs. This, since both variables are squared and the coefficients are different, even if you don't remember this, that, you might recall, is an ellipse. Now, if they were both 3, then they'd be a circle. Or if they were both 2, it'd be a circle. You don't even have to do this. Don't even listen. I don't care. I'll tell you when to wake up, all right? This, what's that going to be? Both variables to the first power, you got to be able to tell me that. Linear! That's right. So, I would hope that one of the pictures that might emerge, it wouldn't surprise you that you're maybe going to get 2 points of intersection. I just kind of like to play that game ahead of time. Hey, what might happen here? I wouldn't be surprised if we get 2 points of intersection. All right, now, the bigger issue, as I keep saying, is whether to substitute or eliminate. Substitution requires that we have a variable by itself. Y equals, X equals, and at first inspection, you hopefully looked at this, you probably looked at this, and you said, there's no X equals, there's no Y equals, I'm going to do elimination. Okay, I'll buy that. Here's the problem though. X squared and X are not like terms, and you can't eliminate them, and neither could you do the Y squared and the Y. So elimination actually cannot be done here because those aren't like terms. So that forces our hand to do substitution. And substitution, I remind you, requires that a variable be by itself. So I would say there's 4 choices here. We could either solve this equation for X and get X by itself. Who wants to do that? Get X by itself. Chirp, chirp, chirp. Nobody. Good. You want to get Y by itself here? Chirp, chirp, chirp. Nobody. Good, good, good. Good call. Who wants to get X by itself in this equation? Yay! Yes! That would be the easiest one. Let's isolate the X in that bottom equation. All we'd have to do is add the Y over to the other side. I'm glad you all cheered when I made that suggestion. This equation becomes X equals Y minus 2. That's a good idea, isn't it? So look, this is just an algebraic rearrangement of that one. Okay, and therefore it can take the place of that one there. Rearrange it. Make it conducive for substitution. So this is really the same equation as that one, it's just in a different format. And so, just to avoid confusion, I'm going to go, hey, bottom equation. I had to rearrange the furniture on you a little bit here, and now you look like this. There you go. And that's the new bottom equation here, isn't it? And that sets the stage for substitution. So now we'll take this expression that's equal to X and plug it in for X in that top equation. There you go. So we had to rearrange that for that to happen. And so this will now become 3, I usually work it this way, but board space, you're tired of me whining about that. 3 times expression squared plus 2y squared equals 5. That's now one variable. Frankly, that equation right there could have been on assignment 11 before spring break. All right? So, moving onward, simplifying that equation. It's quadratic, by the way, so I'll take you back to that. All right? 11. We were in the room together doing these. All right? Oh, those good old days. Remember our good old math photo album? Oh, I remember those days. All right. Now, to simplify it, we would need to distribute that because of the minus. We would distribute this out. Y minus 2, first, outer, inner, last. I'm going to scroll that up here. We had one earlier that resembled this one. So we have 3 times y squared minus 4y plus 4. That's what you get if you distribute this out. What a snob he is. And equals 5. So again, scrolling that up here, and distributing out that quantity. Now what? Distribute the 3. Okay, sounds good to me. 3y squared minus 12y plus 12 plus 2y squared equals 5. I hope everybody's looking at this now. I'm searching for a good vivid marker, trying to make one of these, the ink, work better. I hope you're all going, look at that! Combined like terms. That would be 5y squared minus 12y plus 12 equals 5. Okay, I hope you notice that multiple terms have the variable, which would prompt you to bring over the 5 and make it equal 0. Standard form. Alrighty, so we got 5y squared minus 12y plus 7 equals 0. Standard form. And then we'll factor it if it factors. And I'm pretty sure it does because I made up the question. And I'm being pretty nice to you on these. I could make you do the quadratic formula on these. But anyway, it looks like if we do y minus 1 and 5y minus 7, let's check this so far. First would be 5y squared, last would be plus 7, outer inner, negative 7y, outer, negative 1y, no, negative 5y, pardon me, negative 5y inner. That's negative 12y, all right? You're watching a man, ooh, okay, too much time in a room all by himself. Although most of you are going, yeah, right, you'd be doing the same thing if we were sitting here with you. All right, but anyway, you're right. Calm down. Okay, then I hope I didn't make anybody choke there. I should warn you when I'm about to do that, but you should have seen it coming by now. So if you solve both of these out, you will find that y equals 1. And over here you would add the 7, spaces at a premium, add the 7, divide by 5, and 7 divided by 5 is 1.4. All right, so those two little steps that were left, I got to figure that's no big deal. All right, so two different values of y emerged, which seems to correspond to the two different points of intersection. Almost done. So, what I then suggest we do, hey look, you can always hit rewind if I erase something too quickly. Y equals 1 is one scenario to consider, and y equals 1.4 is the other. Two totally separate scenarios. Scroll them up here, okay? And each one needs a value of x. I'd sure like to find out what x equals. Look at that equation, x equals, it's perfect. That's the one I'd recommend. So, we have x equals 1 minus 2. Put 1 in for y. I should write the equation there, but you can do it. And 1 minus 2 is negative 1. So, now put them in the proper order. Y, we found y first, but y is the second number. And then x turned out to be negative 1. So that's negative 1, 1, isn't it? That's a point. That's one point where these two graphs cross. All right? And then over here, x equals, I'm using that equation again, y minus 2. In this case, 1.4 minus 2. And 1.4 minus 2 is negative 0.6. Make sure you get them in the proper order. X, y. If you recall that picture I had on the board earlier of an ellipse and a line, they passed each other in 2 points, and that's precisely what happened here. So, that's example 4. Again, you'll find I probably will delete example 5 from the notes that I've sent you, because it's just like another one we've done earlier. So we're down to one more example that we'll enjoy together in this particular semester, number 6. It's a bittersweet feeling, isn't it? Knowing that our wonderful time together is almost over, but oh well. Make sure to bring the Kleenex because we're about to enjoy our last example together.